Hello everybody, and welcome to Unit 2, Lesson 3, where we are going to be talking about truth tables. And essentially all truth tables are a convenient chart that can organize all of the possibilities of our statements. So in this case, let's just look at the first part here, where it says negation, right? If we look at this, you'll see that it says for any statement P, if it's true, then what it's saying is if P is true, then what would the negation of P be, right? So in other words, if the car is red, and the car is actually red, because we're saying it's true, then the car is not red. Would that be a true or false statement? Well, it can't be true that it's red and also true that it's not red, right? So this would have to be a false statement. And that makes sense because essentially we're taking the opposite of the statement, right? So let's look at this too. If we said the car is red, but let's say the car was actually blue, right? Then that's false. But the opposite would be true, because if we said the car is not blue, or is not red when it's actually blue, then that would be true, right? So I guess all I'm saying is that when we have the negation of a term, then whether or not it is true or false changes. So let's apply that over here, right? And let's start thinking of what conjunction means. Remember, conjunction is our and, right? So this is our and statement. And remember that for and, both parts have to be true, right? So if P is true and Q is true, if both of our statements are true, then the conjunction is still going to be true. But remember, they both have to be true in order for the conjunction to also be true. So anywhere where one of the two statements is false, this whole statement could not be true. Remember, we learned that last lesson. So we know that these three all have to be false, and this is the one in class that I said it was like super false, right? But yeah, these are all false. So only one in every four situations for an and problem is going to be true. Now let's look at disjunction, which of course when we look at disjunction, we are talking about or, right? Now, or is a little bit different because only one of the two has to be true, right? So anywhere where you see a true, as long as one of the two parts of the statement is true, as long as P is true or Q is true, the statement is true. So if we look here, this one's true and true, so that's obviously true, right? That one's super true, if you will. True and false, well, we only have to have one true, so that one's going to be true. This one's going to be true. And this one, because there's no trues at all, will be our one false statement. So you'll notice that conversely, disjunctions have a 1 in 4 chance of actually being false. More often than not, they are actually true. Now, it gives you a couple tips here on constructing truth tables. You want to include columns from each statement involved. So in other words, if we look at number 1, right, it's telling us that we have a P and an R. Those are both of our statements, right? I know that the R is the negation of R, but just in general, we're talking about these two statements. Now, it also says includes column for any negations. So in this case, we're going to have a column for P, a column for R, and then a column for the negation of R. And only then are we going to include compound statement items. So let's just do an example. I think it'll make more sense. But remember, we're talking about statement P, and we're talking about statement R. So I'm going to put statement P in this first column, and I'm going to put statement R in this second column. Now, for the third column, you'll notice that we have the negation of R, right? It's not just R. So we're going to actually, in this third column, talk about the negation of R. And then the fourth column is going to actually be our compound statement. In this case, we have an or statement, right? So what we are going to do is we are going to write this one out, P or the negation of R, okay? And let's go and get started on this. So all we're doing for these first rows are talking about if it's true, right? So there's 4 possibilities. P can be true and R can be true. P could be true and R could be false. Whoop, false. We could say that P is false and R is true. And we could say that P is false and R is false. Right? These are the possibilities. Does that make sense for P and for R? So, if we know that R is true in this situation, then we also know that negation of R is the opposite. So we know that this is going to be false. We know if it's false, then the opposite is true. This would be false, and this one would be true. And now all we've done is compared R with the negation of R, right? So you'll notice that when R is true, the negation is false. And the reason we're doing that is because in our solution, we need the negation of R and not R itself. So now all we have to do is the thing we did before, right? We're talking about P or the negation of R. So when it's or, only one of those categories has to actually be true, right? So what I'm going to do is I'm going to go up here and I'm going to highlight the rows that we actually care about, right? Which is this row and this row, right? We don't actually care about R. We care about the negation of R. We were just using R to figure out the negation. So that's it. So now we go back here, right? And because it's an or statement, anywhere that it is true in one case or the other, it's going to be true for our compound statement. So this one is true because P is true. This one is true because they're both true. This one is false because neither of them are true. And this one is true because the negation of R is true, right? So when we look at the two columns that are referring to our actual problem, this would be our solution for this truth table. So let's go ahead and look at one more. Let's look at number 3, and then we'll move on to one that's a little bit more complicated. So here we have the negation of Q or R. So how we're going to start this is we need the negation of Q. So first we're going to do Q, and then we're going to do R, and then we're going to do the negation of Q. Now I always try to put the negations all at the end. You could put the negation here and then R over here. It doesn't really matter. You could flip those if you wanted to. So let's go down the list. So if Q is true and R is true, those are possibilities. It could be that Q is true and R is false. That's another possibility. It could be possible that Q is false and R is true. And it also could be possible that Q is false and R is false. They could both be false, right? All right. So now let's look at the negation. On the negation of Q, if Q is true, then the negation is false. If Q is true, then the negation is false. If Q is false, the negation is true. And if Q is false, the negation is true. So now that we're kind of to this final part, remember, all we care about is this column here, because we are talking about the negation of Q, and we are talking about R, which is this column right here. So we're going to look at those two columns, and we're going to make our conclusion for the negation. I don't know why my pen has stopped working. Okay. All right, sorry about the technical difficulties there. All right, we have the negation of Q or R. So let's look at our two categories, right? First of all, it's or. So only one of these two has to be true. So in this case, we have a true in the R category, so this is going to be true. False and false, so this is false. True and true, which is like super true. And then true and false, which is still true because we only need one of them. Cool. And that's our answer. So I hope this is making sense. Let's go ahead and move down to number 5, where it gets a little bit more complicated, but it's exactly the same idea. So let's go ahead and get started on this. So if we have the negation of P or the negation of Q, first let's just do P and Q. And then we'll find the negations after, because then it'll be close to our final solution, right? So P or Q, right? So P could be true and Q could be true. P could be true and Q could be false. P could be false and Q could be true. And P could be false and Q could be false. These are the 4 possibilities for these statements, right? So now if P is true, then the negation of P is false. The negation of P would be false, negation of P would be true, and negation of P would be true. So now the same thing for Q, right? We need to take the negation of Q. And what this will be, let's look at Q. We have true, false, true, false. So this is going to be false, true, false, true. And then our final column here is going to be the negation of P or the negation of Q. So basically, when we're looking at these, we're really trying to find this column here and this column here, right? Which is the reason we did all that work in the first place. And now all we have to do is look at them. All we have to do is have one true, right? If either of these are true, then we're good. In this case, we have two falses, so it's false. Here we have a true. Here we have a true. And here we definitely have a true, right? So that's it. All you have to do is you always take the original statements, find any negations that you need, and then go from there. All right, I will do number 6 with you guys, and then I will let you guys finish off the rest, just because I want to show you what it's like when we add a third here. Now, all this is really saying is that we are trying to find the combination of Q and R, right? So we need to find Q and R first, and then compare that to P with this OR statement, right? So first we are going to find Q and R, and then find out which among those are true, and then find P and find out which among those are true, and then just find ones that are true for one or the other, just like before. So I'll show you an example of what I mean. So our first thing, we have a P, a Q, and an R. I'm going to start with the two letters that are inside the brackets, because we're going to work with those first. And you notice we don't have any negations, so this really isn't too bad. So we're going to start with Q. We're going to start with Q and R. And then our last statement here is P. So we'll put this one here, right? So let's look at this. Q could be true, R could be true, and P could be false. Or let's do true. Let's just do all the truths at the beginning. So it's true that all three of them could be true, right? It's also possible that Q is true, R is true, and P is false, right? Could therefore be true that Q is true, R is false, and P is true, right? So now we have all the truths for Q. So let's see, what else could it be? It could be true, false. Oh, no, it could be possible that this is true and that both of these are false, right? That could be true. Okay, so yeah, we have our 4 truths. So now we have false, and then it's possible that this is true and this is false. And then it would be true, false, false, true. And then false, what would this be? False, true, true, right? And then the last one would be false, false, false. All right, so here we've listed all of the possibilities, right? If Q is true, these could be true or false, and accordingly. Now, let's look at our statement. So in this case, we don't have any negation, right? So we don't need to do any of the negations, but we are looking first at Q and R. So what I'm going to do is in this category here, I'm going to do Q and R, and I'm going to figure out where those are true, right? So I'm looking at these first 2 columns. So where Q and R are true, this will also work. So this is true because Q and R are true. Q and R are true in this one. That's so far so good. This one is false because the R is false, so that doesn't work. This one is false because R is false. This one is false because R is false. Or Q is false, sorry. This one is false because they're both false. And false because of Q, and false because of them both. So now we've established Q and R. But what we want to know is Q and R or P. So this is Q and R, right? We know that Q and R is true for these statements and false for the rest. And then we know P is true and false based on here. So what we're going to do is our conclusion is going to be this category, right, for P. But then we're also looking at the category for Q and R. So we're going to take this category, and we're going to take the OR of those 2 categories. So all we're going to do is come over here. We're going to have P or Q and R. And we're just going to go down the list, right? And because it's an OR problem, only one of these has to be true. So in this case, we're definitely true. We're true here, false here, false here, true here, and false here. And that's the final answer. You'll notice that because it's an OR problem, right, we still have, 1, 2, 3, 4, 5. 5 out of 8 are true. So we're still going to have more truths than false. Um, yeah. So this is a more complex example. If you go down to number 7, you'll see there's a negation. So all you'll have to do is also take the negation of Q to make sure that you're actually comparing to the negation and not the original statement. But I'll go ahead and let you guys try that one. Obviously, if you have any questions, please come see me and I'd be happy to help. But that is the end of this lesson, and I will see you guys next time.